Good evening to everyone. So today we are going to see another renewable form of energy, that is thermal energy storage system. That is a phase change material, right? So phase change material basically works on a latent heat, that is heat that is required to change the phase of a material, for instance, from solid to liquid or liquid to gas. So if imagine that you are having an ice cube at 0 degrees Celsius or at sub-zero degrees Celsius, that is temperatures less than 0 degrees Celsius, that is -10 or -15. So the heat you require to increase the temperature of ice from -15 degrees Celsius to 0 degrees Celsius is called as sensible heat. That is heat which is used only for rising the temperature of a substance, that is called as sensible heat. Whereas in 0 degrees Celsius, the ice will change to water. That is a solid, it's converting into a liquid. So to convert a solid into liquid at its melting point, right? Heat supplied at a constant temperature, that is its melting point, is called as latent heat. So why it is called as latent heat? It is a hidden heat. Latent has a meaning hidden, right? So these phase change materials uses this latent heat to store and release energy, right? So materials such as wax with high latent heat storage are utilized for this process, for having a PCM capsule or a PCM module or whatever, right? So let me share the presentation. So thermal energy storage with phase change materials. So what is thermal energy storage? So thermal energy storage is nothing but storing the heat for later use. So you have dynamic systems where energy is produced and it is utilized, or energy is utilized as it is produced. So these thermal energy storage systems produces energy and stores heat for later use, right? So such storage will improve the energy efficiency of overall system and grid stability. So thermal energy system can use sensible heat, latent heat, or thermochemical storage. So as I already told, sensible heat is heat that is utilized for increasing the temperature. Latent heat is heat that is used for phase change. And thermochemical storage. For example, you are having a liquid and an electrode. So the chemical reactions can happen and heat produced can be stored. That is a thermochemical storage. So phase change materials are used for storing energy through melting and solidifying. So it can be easily solidified and or easily melted. So it is used in HVAC, that is heating, ventilation and air conditioning, solar energy and industrial applications. So what are PCMs? So phase change materials, as I already told, absorb and release heat by changing the state. For example, if a solid is converted to liquid, so you have to supply latent heat, right? So a phase change material, a PCM, what it will do, it will absorb heat to get liquefied. So to get liquefied, it will absorb heat. So it will store energy by liquefying itself. So when it is liquefied, it means that it is storing the energy, right? Similarly, again, when it solidifies, it will release that energy. It will reject that energy, right? So when it is converted to solid to heat liquid, it is storing energy. That is, it is used as a thermal energy storage. And when it solidifies again, it is releasing energy. So PCMs can store large amounts of energy with minimal temperature fluctuation. As I already told, the heat which is required for solidifying or liquefying happens at constant temperature, right? So there is no temperature change. So phase change materials can store large amount of heat with no or minimum temperature fluctuations, as all the heat absorbed at constant temperature. For example, if it is converted to solid to liquid, all the energy absorbed is happening at the melting point of that solid, right? So, or when it is solidifying from liquid to solid, it releases energy at that constant temperature, at that melting point, right? So that is the major advantage of the phase change materials. So what are the common examples? Paraffin wax, salt hydrates, fatty acids are commonly used phase change materials. So they are selected based on their melting point and thermal property. So what here mentioned as thermal property, right? So what is this thermal property? It is nothing but latent heat. So as we all know, latent heat of high ice is nothing but 335 kilojoules per kilogram. So at 0 degrees Celsius, only when you supply this quantity of heat, ice will be converted to water. So the thermal property is nothing but latent heat of that particular phase change material, or latent heat means heat that is required at melting point of the material to change its phase from solid to liquid, right? The phase change materials are classified as organic PCMs, which includes paraffin waxes and fatty acids. They are non-toxic, chemically stable, and have a predictable melting and freezing point. This is very important, having a predictable melting and freezing point, as it will be easier for us to model the process. So here now we are modeling the process using various softwares. So when the organic PCMs have a predictable melting or freezing point, it will be easier. Inorganic PCMs, inorganic phase change materials, which are made of salt, hydrates, and metallic materials. Inorganic PCMs offer high energy storage capacity, but melting or freezing points may not be predictable as organic PCMs, right? So these two has their own advantage and disadvantage. For instance, organic PCMs have relatively lower energy storage capacity as compared to inorganic PCMs, but they have predictable melting and freezing point. And this inorganic PCMs have a high energy capacity, but the melting or freezing point is not predictable and have stability issues. So there is another research is going on eutectic PCMs, which combines these two in various ratios, so that the optimization of the capacity and the modeling can be combined. Mixture of two or more substances with melting point lower than individual components is called as eutectic PCMs. So it will give better efficiency and better thermal stability and better capacity, right, as compared to the individual things, right? So this is the working principle of phase change materials. That is a heat source which provides heat. PCM unit absorbs the heat and melts. In the process, it stores the energy, and when it cools and solidifies, it releases heat, which is released heat is used for energy storage systems such as HVAC systems, industrial heating, and renewable energy storage, right? So this is a highly efficient cooling system, which is a wide range of applications. So students can think of projects, right, to use. For instance, I have thought of a project which uses heat from the car cabin, a PCM module mounted in a car cabin. So when we park our car in hot summer, so heat that is inside the car can be used for melting a PCM material which is in a PCM module. So heat stored in the PCM module can be used for some other purposes. So when you open this, PCM module will absorb all the heat in your cabin, right? And the cabin will be cooler. And when you are running the car, the heat shall be released from the PCM module, so that can contribute to your battery, right? So this is a simple project idea which students can work on, right? So we will see on another topic some other day. Thank you.